Today we talked about exponential functions. Remember, this number is A, this is B, this is H, and this is K. H is always flipped. So H is not a plus 1. H would be a minus 1. K would be a minus 4. A would be a positive 2. So let's start with H being negative 1. What does that make our graph do? Left, right, up, or down? Left. Left 1. K is negative 4. What does that make our graph do? Down 4. A is positive 2. Does that make it stretch or compress? Stretch. Okay, Michael. I got one person with me. That's all I need is one though. All right, now let's look at the base. Whenever this number is greater than 1, it is growth. 3 is greater than 1. So that means that this is a growth function. Growth function is going to increase. Okay, now let's look at our note packet. I did confirm with the team. Our test is February 13th. So go ahead and write that on the front of your purple packet. Our next test is Friday, February 13th. So you can go ahead and write that down on the front page. That's our next test. Okay. So let's go to page 4. We got one more graph, one more growth decay. So let's start off by graphing the parent. This is our parent. We're going to use the numbers 0, 1, and 2. We're on page 4. Page 4. Now, every single parent function, if you have an A of 1, an H of 0, and a K of 0, your domain is all real numbers. Your range is 0 to infinity. And you have an invisible asymptote at y equals 0. Yesterday we talked about any number or letter or name or person to the power of 0 is 1. 3 to the first is 3. 3 to the second is 9. So let's go ahead and fill in. Let's graph it. 1 up 3. 2 up 9. And when you graph it, you have to make sure that you don't do this. Does everybody see what I just did? That's a big no-no. We don't do that. Exponentials, they go straight out above the asymptote. It cannot go under y equals 0. That's what I'm looking for. Okay, so now let's look at our second function, which is this one right here. This one has an A value of -1, H is -1, and K is -3. So A equals -1, which is going to make it reflect down. Your H is -3, which makes it go left 3. And K is -3. That makes it move down 3. For an exponential function, K is the superstar. That's the MVP. K tells you your range. It also tells you where to draw in your horizontal asymptote. K is very, 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 very important for an exponential function. All right, so now let's go ahead and apply our transformations. So when we apply our transformations, it's h plus x, which is going to be -3. Go ahead and add -3 to all of these numbers. To the y side, we're going to multiply them by a and then add k, which means I'm multiplying it by -1 and then I'm subtracting 3 all the way down. So take a couple minutes and find your new x and y values. Go ahead and make a little line because, okay. So for your x values, you're adding -3. For your y values, you are multiplying them by -1 and then subtracting 3. Bear Kid, you need a calculator? You need one? Alicia, can you pass that to her? To him? Thank you. Anybody else need a calculator? My domain is still all real numbers. So because my k value is -3, I want you to draw in a dashed line at -3. Horizontal dashed line. This line is very important because the graph cannot go through that purple line. It cannot go through that purple line. So let's go ahead and graph our 3 points. So -3, down 4, -2, down 6, -1, down 12. So it's going to come in really close to that. This time it's a ceiling because it's above it. But it doesn't go through the ceiling and then it goes straight down. That's what your new graph should look like. Okay. Now, so I drew my ceiling in at y equals -3. So let's go ahead and write that for my horizontal asymptote. But this graph is upside down. So the lowest it goes is -infinity. -infinity comes first because it reflects. And the highest it goes is, it doesn't get there, but it approaches -3. Oh, thank you so much, Ashley. No, I have not seen her. No, ma'am. She wasn't here. I don't know where she at.
Thank you.
You're welcome. Okay. Any questions about example 5? So now let's talk about decay. Let's talk about decay. So remember, if your base is bigger than 1, it is growth. If it's between 0 and 1, it is decay. So we're going to graph both of these. So let's start off with y equals 2 to the power of x. All right, this is growth. This is growth because 2 is greater than 1. I'm going to graph this one on this side. So we're going to use the numbers 0, 1, 2, and 3. And these are my y values. Go ahead and graph those numbers. That would be my first graph. Somebody in one of my 3 integrated classes, I don't know which one, turned in a review with no name or period. So nobody claimed it first, nobody claimed it second. Maybe it's in this class. So at the end of class, please go check to see if that is yours. And if it is yours, write your name and period and turn it back into the tray, and I will give you your points. All right, so that's my growth graph. So now let's look at the second one. 1/2, this is less than, this is not greater than 1. 1/2 is a fraction. So that would be decay. So this function is decay. So the difference with decay, though, is that I'm going to use 0, -1, -2, and -3. So with your calculators, I want you to type in, you don't have to use 1/2. You could also do 0.5. 0.5 might be easier to type in. So type in 0.5 to the power of 0, and then 0.5 to the power of -1, 0.5 to the power of -2, 0.5 to the power of -3. Go ahead and type it in. What do you notice about the numbers you got? If you compare the numbers you got for these functions to these, what do you notice about your 2y values? They're the same, right? The big difference for decay is that we have to use negative x values. But these numbers are the same. So let's go ahead and plot those. So we got 0, 1. And then I have -1, 2. And then -2, 4. And -8, or sorry, 3, -8. This is what it should look like. So you got your red graph and you have your green graph. It's going to be a struggle to make it through today. I got a feeling by 7, I ain't going to have no voice. They may have to watch the video. What do you notice? What happened to the green and red graph? What happened to it? What did it reflect across? What axis did it reflect across? The y-axis. That's all that happened. Every single point moved across the y-axis. So what happened is, how is each point on y equals 2 of x being moved? It is reflecting over the y-axis. That's what's happened. Does that change our domain and range? No. Both of those graphs have the same domain and range. They both have a domain of all real numbers and the range is 0 to infinity. No brackets. The only difference is that one goes across the y-axis. That's our only change. Okay, so let's do one more graph and then we're going to end there. We're not going to end there. We're going to end graphing. Then we'll do some word problems. So our next function is decay. So I want you to regraph this parent function that we just graphed. Use this same table. We're going to graph that again. So we have x and y, 0, -1, -2, -3, 8, 4, 2, 1. Let's go ahead and graph that. All of this goes with that function. Has a horizontal asymptote at 0, a range of 0 to infinity. Domain is all real numbers. That's for all of them. All right, so let's go ahead and graph it. And make sure you don't go under the x-axis. Okay. So now let's look at our second graph. We got some transformations. Now they want us to take our graph. Two things are going to happen. The A value is still 1. So it doesn't reflect, stretch, or compress. Look in your exponent and flip the sign. So is h -2 or +2? What's h going to be? +2, which is going to move it right 2. So I'm adding 2 to all of these numbers. Now the MVP is k. K is +1, which is going to move our graph up 1. So I'm adding 1 to all of these numbers. Okay. So what I'm going to do before I graph anything, I like to draw in my horizontal line where K is. So I'm going to draw that in. This is my new asymptote right there. So take a moment. Come up with your 4 new points. So for X, you're adding 2. For Y, you're adding 1. I'm going to go ahead and freeze my screen, and you find out what your numbers are. So this is what my graph looked like. So if you compare the red to the blue, it just moved right 2 and up 1. All 4 points. So the domain didn't change. That's still all real numbers. But my range because I moved my floor up, it's no longer 0 to infinity. Now it's 1 to infinity. No brackets. It will never be 1. It'll be 1.0000000000005, but it'll never be 1. That's why we don't put a bracket. And my new asymptote is at y equals 1. Okay, so now we're going to get to the word problems. We're going to skip that next graph. You can go ahead and cross that out. And we're going to talk about exponential growth. The formula for exponential growth. All right, so take a moment, copy down this formula. So we have our A value. That means that's my ending amount. And then the P value, that's my starting amount. The rate, that's my percentage. And then I have T, which is time. So go ahead and copy that down. Now, when we're talking about growth, whenever we're talking about growth, growth is addition. That's why there's a plus sign here. That's really important. The other thing that's important is that when you have a rate, your percentage, because your rate is going to be in terms of a percentage, you have to divide that by 100. So we have to change the percent to a decimal. And we do that by dividing it by 100. So we got the population of Albany, Kentucky. It is growing. This is the key word, is growing. It's growing at a rate of 2%. So you have to find your rate. You're going to take 2 and divide that by 100, which is going to give you 0.02. The biggest mistake is that people will say 2% is 0.2. 2% is 0.02. The starting population is 25,000. So let's write our function rule. When we write our function rule, it's A equals 25,000 parentheses 1 plus your rate to the power of t. So when we're writing our rule, we leave the t a variable. Now, we're going to use that same rule to figure out the actual population. And we're going to substitute in a 5. So I want you to, with your calculators, type this in. Use your parentheses. And we're talking about people. So we don't have a decimal. I just want the numbers in front of the decimal. I do not want a decimal. There is no decimal of a person. Every person is whole, period. Whole people. Let me make sure everybody is typing it in right. That's 2,500. And it's 0 point. You have to use the decimal. 0.02. So you should get 27,602 people. Don't forget your unit. Okay, let's go to number 2. Now we're talking about deer. Sweet little Bambi. So deer is growing at a rate of 3%. So 3 divided by 100 is 0.03. My starting population is 10,000. So when I write my rule, A equals 10,000 parentheses 1 plus 0.03 to the power of t. When you write your rule, you leave it a t. Now use that rule, substitute in 10 for t. Just like people, we can't have a piece of a deer. A deer is a deer. No decimals. Only give me the numbers in front of the decimal. And don't forget your unit. The unit is deer. Even though they changed it to a bison, that should be deer. I'm going to try to remember to change that for next year. So we get 13,439 deer. Who had that answer? All right, do the next one by yourself. I'm going to come around and see who got it right. And the unit is students. Right, I'm going to come around and check our answers, see who got what I got. Start over here. Good, that's good. Okay, that looks good. All right, this is the answer I got. All right, now let's take out homework 5. I'm going to give you your tables. Homework 5 is due on When does it due? Tuesday. Tuesday. Homework 5 is due to homework 5. Okay, sorry. Module 5, homework 1. Module 5, homework 1 is due on Tuesday. Tuesday, February 3rd.